Hi, my name is James Lee, and actually I'm local from China Mobile. We have a office in Milpitas, and as David Kingsley mentioned earlier, we also host the OSC, the West Coast Open Lab in our office as well. So today it's my great pleasure to actually present on behalf of the RICAPPs project, because the PTL, Sunil, he is not able to make to the summit in person. So the idea is to have you have an overview of what we have accomplished over the years in the RICAPPs project and the associated use cases. Well, this is a quick the agenda. So first I will cover some of the introduction, like what is the primary goals for our RICAPP project. And certainly, as you already heard from David, the XApps are mainly associated with the E2 interfaces. So naturally, we will talk about what are the frameworks and the E2 support related to the RICAPP project. And then we will go over what we have installed of the XApps. We have 10 plus XApps and ongoing. After that, I will do a deep dive into a couple of use cases, mainly with the traffic steering. So with traffic steering, actually, we kind of grouped 4 XApps together, to fulfill the traffic steering. And we think that it also has the AD, which accounts for the anomaly detection, and the QP, which is the quality of experience predictor, those 2 XApps together, to complete the traffic steering. And afterwards, we will talk about a little bit into the future for the proposed use cases in XApps and provide you with some references. Okay, so the primary goal of the RICAPP, the project certainly is try to establish the open source implementation of XApps, as well as we call it framework application, because with the near real-time RIC platform, there are different we call it XApp frameworks that support different programming languages. Just imagine like the Android SDK. So with those SDK supporting different programming languages, it eases the development for XApp programmers. And actually, you will see, like for the traffic steering, we have a bunch from AT&T, the operator. We have academics from the Paraná University from Brazil, as well as multiple vendors putting efforts together, right, to achieve such innovation for traffic steering. At the same time, certainly, we try to grow this base of XApp inventory to showcase what the ORAN, the source community can support. And at the same time, along the way, within OSC, we have the so-called RSEC. It's called Requirement and Software Architecture Committee. This is like the committee that oversees the development process for each of our OSC releases. So it collects the requirement and put together, what we try to implement along the way. And here, we also listed a current inventory of XApps that's in place today, including traffic steering. We have various health check. And certainly, within the XApps, it demonstrates how the lifecycle management is enforced. And currently, together with the MVPC, the Minimal Viable Plan Committee, we try to implement the energy saving use case as well. Certainly a very important goal, as we already showcased before is like with our X app, it needs to show it conforms with our ORAN specifications and certainly align with the use case specified by our MVPC as well. Another most important feature it has to do is also to try to maintain and support the all the existing and new X apps to our latest software releases. So you can imagine along the way when the near real-time RIC platform, when they implement new features such as new E2 APIs into the framework, then from the X app perspective, we also will demonstrate the implementation of new features based on the new addition of such features from the framework. All right. Well, when we talk about this framework, I would say the OSC, the SDK, so far provides the widest language support. We have 4 programming language support today for SDK, for X app development. So you will be able to use C++, which is the very first one, and along the way we have added Python and Golang, and the Rust programming language was the very latest one that we added from the last release that was released by end of last year. And in terms of the support of the E2 interfaces, we have the E2 AP, the application protocol, and E2 SM, the service model support. So right now, we're at the E2 AP 2.0 support. And in terms of the service models, we have the support of the KPM to the version of 2.0 and the RAN control to 1.0.3. So at the same time, the CCC, the cell configuration and control, that service model, we have CCC XApp in progress, so it's not there yet. So in terms of what we already have for the XApp inventory, we split into different categories. So the very first one is certainly a showcase what an XApp can support the corresponding the basic frameworks. As I mentioned, there are 4 different programming language framework today, and for each of them we have XApp, which called the hello world, just like you're familiar with a programming language. The first thing it demonstrates is how to print out this hello world message, right? But with our XApp, actually it does a lot more to for the hello world. Usually it includes features like how an XApp registers to the RIC platform, how it interacts with all the like the E2 subscription, and how it interacts with the underlying, say, the shared data layer, the database access, and a lot more. So as you can see, the first one for the C++ is just called the HW, right, the hello world. But afterwards, because of the new addition of programming support, so we just add the name of the language to the XApp names. And also for the service models, we have KPI-Mon, and we have KPI-Mon Go as well, just for the using the Golang to demonstrate the KPM service model to collect the matrix from the underlying E2 nodes. We also have the RAN control that XApp, which can send the RIC control messages to the underlying the E2 RAM node, and it conforms to 1.0.3 version of that service model. For the CCC, as I mentioned earlier, it's still in progress for our development, and we hope it can be ready in the current J release by the end of this June. In terms of the use case support, the major one we can showcase It's the traffic steering use case. It's ready actually by the D-release timeframe, and we still continue to enhance by adding new features, right, to each of the components. Say, for example, right, we have more addition to the KPI among when it will be able to collect more KPM matrix based on the evolving of the service model. And for the AD and the QP, we have implemented the AI/ML based models for the training and inference. And certainly the traffic steering is just like the brain, right, to have all this information put together and to make the decision whether it needs to do the traffic steering based on the UE and the cell config situation. There's one very special one. It's called the Bouncer XApp, which is our benchmark XApp for the RIC platform. It's able to measure, the control loop, like how you do the E2 insert and control this latency measurement, as well. It will be able to measure what is the bottleneck of when you're adding E2 nodes. So it's able to benchmark on how many E2 nodes it will be able to support for a given E2 platform. We have others as well, like LP. It's called the load prediction XApp. It's also an AI/ML based XApp, as well as the MC, the measurement campaign XApp, which is used for the 5G ENDC, the KPM calculation. So now let me go into a deep dive of our traffic steering use case. So as I mentioned, this is a joint effort from academics, which is from the University of Paraná, from Brazil, from AT&T, and we have multiple vendors, HCL, Viavi, Samsung, and Nokia as well. Since OSC does not have the E2 node, like the RUs, we use the Viavi simulator to generate the KPMs. So the KPI among the XApp will collect all the details from the KPM subscription and writes into the InfluxDB in terms of the UE matrix and the cell matrix as well. So for the AD, the anomaly detection XApp, it's actually consumed the UE matrix. So it constant query, and based on its saved model, it will do the corresponding inference to determine whether there is anomaly detected, and it will update to the traffic steering. So at the same time, the QE prediction XApp will consume the cell metrics, and it will prediction based on the cell information. It will give us what is the uplink and downlink throughput prediction to the TS XApps. So once there's a need for traffic steering based on the anomaly detection, so the TS XApp will use the QP output to determine which is the cell that it can do the handover with. This is the flow of the underlying anomaly detection XApp. So it's split up into two major parts. One is in the training part. Certainly, with this XApp itself, we'll be able to run into a training mode, which into the future, I believe, with a more solid AI/ML framework, we should be able to distribute all the training and the model saving all the lifecycle management into the AI/ML framework. But meanwhile, when it was developed, it has to take care both the training as well as the inference as well. So I will not go into all the details, but it follows the general the training pipeline, and at the same time, for the inference part, once a model is deployed, then the main flow will be able to query constantly with the live data from the InfluxDB, and then does the inference and send over the classification result to the traffic steering XApp. Similarly, it's for the QP XApp as well. So it also split into the training and the inference two parts, and basically just consume a different type of data for the cell matrix to work in tandem with the traffic steering XApp. Okay, so into the future, we have some proposed use cases, and we keep in mind like what we're going to do in the next release also. The major one is the energy saving. Well, not necessary it's an XApp because energy saving not necessary. It's need to be executed right at such a short time scale. So most likely it's going to be an R app. But based on all the cell load prediction, it will be able to like switch off a cell or the carrier to optimize the energy consumption. There are additional ones like network slicing or geolocation XApp that can do the prediction based on calculation of the next location of the UE. We also have some others like the mobile load balance use cases for load balancing as well. If you wanted to look at more details, we kind of conform to the workgroup use case analysis report, this version 13. There are currently about 26 use cases to be considered into our XApp development. Some references, basically, the overall, the ORAN SC community and into RIC XApp. And we have our meeting, we have our the wiki page, we have our the Jira tickets, so you can look all the details. And also, because OSC is a sample, the reference implementation of the ORAN, so we work very closely with the standardization, with the specification as well. So we also listed, the corresponding the links to the reference over there. Well, as John demonstrated, like how an R app is you can onboard and to the lifecycle management. Actually, in the RIC app, we have a similar process that you can onboard an XApp and monitor its health check, all that things. But we are not covered, in this speech. But you are welcome if you have questions to ask regarding that aspects. So that's about it. I think we have a few more minutes if we need for questions. Yes, I think it should be a part of the system, like what the AI/ML framework is developing and into the future, because it should be able to take care all the need for the training, like the data management and also all the model management as well. So supposedly, it will be able to provide a more friendly and to offset, right, all the burden to the framework that's being developed. So just like the XApp framework, right, the training and the inference should be moved forward to the framework as well.